I'm going to do just a quick little review of the first 3 units that we've looked at. So we've done some estimation and order of operations, area, perimeter, Pythagorean theorem, volume. So just a quick review, mainly formulas, because that's the key concepts that are really there that we've been working with a lot, is just applying and using those formulas. So to go over some of them, and then I'll take in a couple ideas along the way. So we start with a rectangle here. We have generally labeled length and width, and the formulas that we have is the area is the length times the width, and the perimeter is 2 lengths plus 2 widths. Remember, when we're working with perimeter, we're looking at the distance around the outside of the object, and when we're working with area, we're working with how many little squares we can break this up into. A couple things to note when we're working with rectangles. If it's a square is a rectangle. It's a special form of a rectangle where all the sides are the same length. And if you want to maximize the area of a rectangle, so if you want to maximize area, so when you want to maximize the area of a rectangle, use a square. Okay, so square will have the maximum area given any perimeter. Another one we spent a bunch of time with is the triangles. So again, we have perimeter, we have area. So the area is the base times the height divided by 2. Or we've also used 1/2 base times height. You'll see it written different ways. But as long as you have a base and a height of the triangle. In the case of the second triangle here, this right triangle, we can use the A and B as our base and height. This would be our hypotenuse. And we do not use that as part of the area. The perimeter of a triangle is just the sum of all 3 sides. Generally we say A plus B plus C. And even in this triangle here, this could be A and C. The other big one that we've used is Pythagorean Theorem. So Pythagorean Theorem is A squared plus B squared equals C squared. And again, that's for right triangles only. This only works in a right angled triangle where A and B are the short sides and C is the hypotenuse. When working with circles, we have our area being pi r squared. And so we just take the radius, which is half of the length across the circle. And then the perimeter, or circumference, as we usually call it in a circle, is pi d, pi times the diameter, or 2 pi r, 2 times the radius and pi. Remember, pi equals 3.14 when we want to use that, unless you have the button on your calculator. And then we've done some work recently with the volume of some shapes. So we have the volume of a prism is the area of the base times its height. So the volume of a rectangular base prism here is the length times the width times the height. Volume equals length, width times height. In the case of a triangular base prism, it's the area of the triangle times, and I use depth because we often use height with the triangle, but as long as you're multiplying the three dimensions together, that's all that's important. So volume equals the area of the triangular base, 1/2 base times height, times depth. And then our latest two that we worked with would be the cylinder. Last prism, and then I missed the cone on here. I'll have to put a cone in for you. The volume of a cylinder is pi r squared h. Cylinder is a circular base prism. The volume of a sphere is 4/3 pi r cubed. And I'll just add one up here. A cone the volume of a cone uses the radius and the height of that, so the volume is 1/3 pi r squared h. So those are all our key formulas for area, volume, circumference, perimeter, and the Pythagorean Theorem. Again, any assessment, we always provide those to you, but good to be familiar with. And then the last bit here at the bottom, we talked about capacity to volume. When we're calculating the volume, that's how much space something takes up, where the capacity is how much would fit inside. So the capacity to volume, the capacity usually measured in liters. In our case, 1 liter is equal to 1,000 cubic centimeters, or 1 cubic meter is 1,000 liters. So those are our key formulas. The one set of examples I'd like to do is just a quick little set of Pythagorean Theorem for you, because I know that one's tends to be a little more complicated of all the formulas. So if we got a right triangle, we'll do 2 questions. And I'm going to pick some super easy numbers so I can get away without a calculator. But if we have a triangle like this, a right angle triangle, we have the 2 shorter sides, 3 and 4, and we want to find out side C, the hypotenuse. So the longest side again pointed at by that little right angle there. We write out the formula. A squared plus b squared equals c squared. We fill in what we know. A and b could be either one of these, it doesn't matter. So we could have that as 4 is a or 3 is a. I'm just going to do 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. So we just calculate those. Now we can add them. 16 plus 9 is 25, which is c squared. And then to calculate the actual c value, we need to take the square root of both sides. Remember, the square root is the opposite of squaring. So if we're squaring c and we take the square root of that, we get c. The square root of 25 asks what number times itself. What number squared is 25? That's 5. So that is our missing side C. And again, remember, this is the 3, 4, 5 triangle. That's one of those ones you want to become familiar with. Very commonly used triangle because of its use in construction and things like that. One more example here. We'll take a case where we're trying to find one of the shorter sides. And we'll do a 10 and 8 8, and we'll call this one A. So we're going to try and find side A. It works the same as if we were trying to find side B as well. We write out our formula. A squared plus B squared equals C squared. Fill in the values we know. We don't know A and B. This is side C. This is the hypotenuse. So that's side C. That would be side B. So when we fill in our formula, we have A squared plus 8 squared equals 10 squared. Like that. Now we do our squaring. A squared plus 64 equals 100. Now we're adding 64 to this side. If we want to get rid of the 64 from this side, we have to subtract it. So we have A squared plus 64 minus 64 equals 100. Now, because we subtracted something from one side, to keep everything equal, we have to do the same thing on the other side. So we subtract 64 from both sides. 64 minus 64, that goes away to 0, and we're left with A squared. And on the other side, 100 minus 64 is 36. Now we take the square root of both sides, square root of A squared, square root of 36, and we're left with A equals 6. So that there is an example of working with our Pythagorean theorem. Couple other things to note. Remember, bedmass is always used. We always use bedmass, brackets, exponents, division, multiplication in whatever order they come in, addition and subtraction in the order they come in. And when we're working with things like composite figures, we will break them up into little bits and pieces, and you should be able to get through the questions I've put up. So it's labeled as 3.3. It's a cumulative review of chapters 1 to 3. And I want you to try a bunch of the questions here. This will really make sure that you're remembering everything. But questions number 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 questions. Sorry, put that on the screen there. 9 questions to try out from the worksheet 3.3. That's in the library section on Edsby. So you can check that out and make sure you're asking questions. You can use Edsby, or you can send me an email, whatever works best for you.